A-level mechanics, vertical motion, projectiles. Let's have a look at what we mean by projectiles. When an object is thrown, it moves through the air under the force of gravity. We call such an object a projectile if 1. It can be regarded as a particle, that is, it can be regarded as having all its mass at a point. 2. Gravity is the only force acting on it. And 3. It's not affected by the air. In other words, air resistance is negligible and no lift is generated. Now consider a projectile launched from the origin with a velocity v at an angle theta to the horizontal. And taking up as positive, the projectile will follow the path of a parabola. We can resolve its velocity horizontally and vertically. The horizontal component, which we can call u little h, is equal to v cos theta. The vertical component, which we can call u little v, is equal to v sin theta. Now consider the particle in the air after time t. Let its position be xy. It has the force of gravity, mg, acting vertically down. Let the components of its velocity be v little h and v little v. Resolving horizontally, there's no horizontal force, so vh is equal to uh. The final horizontal velocity is equal to the initial horizontal velocity. In other words, vh is equal to v cos theta. Also, the distance travelled is equal to the speed times the time, so x is equal to u little h times t. So x is equal to vt cos theta. Now if we resolve vertically using F equals ma, we get minus mg equals ma. So a is equal to minus g. The acceleration of the particle is g downwards. Now on Earth, g takes the value of 9.8 meters per second squared. So using v equals u plus at, we have v little v equals u little v minus gt. In other words, the final vertical velocity is equal to the initial vertical velocity minus gt. And if we use s equals ut plus a half at squared, we get y, the height, equals vt sine theta minus a half gt squared. And these are the fundamental equations for a projectile. We can put them in a table. Horizontally, we have the acceleration is naught, the velocity is v cos theta, and the displacement is vt cos theta. Vertically, we have the acceleration is minus g, the velocity is v sine theta minus gt, and the displacement is vt sine theta minus a half gt squared. Note, it's worth mentioning Newton's notation which he used for velocity and acceleration. He used x dot to mean the differential of x with t, which is the velocity in the x direction, and x double dot to mean the second differential, which is the acceleration in the x direction. So we have horizontally, the velocity is x dot, which is equivalent to v small h, and the acceleration is x double dot. Vertically, we have the velocity is y dot, which is equivalent to v small v, and the acceleration is y double dot. This notation is quite commonly used. Now there are various properties we can find out about the flight of the projectile. And the first one is the maximum height. Now we can see, at the maximum height of the trajectory, the vertical component of the velocity will be 0, and we can use this to find t. Using v equals u plus at and resolving vertically, we get naught equals v sine theta minus gt. This means gt is equal to v sine theta, or t is equal to v sine theta over g. Now we can substitute this in the equation, y equals vt sine theta minus a half gt squared. So we get the maximum height y max, is equal to v into v sine theta over g times sine theta minus a half g and in brackets v sine theta over g all squared, which simplifies to y max is equal to v squared sine squared theta over g minus a half v squared sine squared theta over g, or y max equals v squared sine squared theta all over 2g, which can also be written as, in brackets, v sine theta all squared divided by 2g. Although in a problem the maximum height could be worked out using this formula, it would probably be better just to remember to find t when the vertical component of the velocity, vv, is equal to 0, and then find y. Let's look at an example. A projectile is launched from the ground at 30 degrees to the horizontal with a velocity of 39.2 meters per second. Find its maximum height. Now to solve this, we can use the equation the vertical velocity, that is v little v, is equal to v sine theta minus gt. But at the maximum height, the vertical velocity v little v will equal 0. So we have 0 equals 39.2 sine 30 minus 9.8t, which gives us 9.8t equals 39.2 sine 30, and because the sine of 30 is 0.5, we have t is equal to 39.2 times 0.5 over 9.8, which works out to be 2. Now, using y equals vt sine theta minus a half gt squared, we've got v is 39.2, t is 2, and sine theta is a half, so y is equal to 39.2 times 2 times 0.5 minus a half times 9.8 times 2 squared, which is 39.2 minus 2 times 9.8, or 19.6 meters. So the maximum height is 19.6 meters. Another useful projectile formula we have is the time of flight. If a projectile is launched from the ground, then the time it's in the air until it gets back to the ground is called the time of flight. It gets back to the ground when y equals 0. If we consider the equation for vertical displacement and let the height be 0, we get vt sine theta minus a half gt squared is equal to 0. Now that means either t is 0, or we can divide by t and get v sine theta minus a half gt is equal to 0. And that can be rearranged as t is equal to 2v sine theta over g. And this is the time the particle is in the air. So the time of flight is 2v sine theta over g, which is twice the time needed to reach the maximum height. The next useful formula is the range. The range of a projectile is the horizontal distance it covers before it hits the ground. In this case, we know that the horizontal distance is given by the formula x equals vt cos theta, where t is the time of flight, so t is equal to 2v sine theta over g. Substituting, we get the range is equal to v into 2v sine theta over g cosine theta. Now that can be rearranged as the range is equal to 2v squared sine theta cosine theta all over g, but we have a formula sine 2 theta is equal to 2 sine theta cos theta, and so we can simplify the range. The range is equal to v squared sine 2 theta over g. And from this we can derive the maximum range. When a particle is projected from the ground with a given speed, the range depends on the angle at which it's fired. And the question is, which is the best angle to give the maximum range? Now we have the range as v squared sine 2 theta over g. But sine 2 theta has a maximum value of 1. That's when 2 theta is equal to 90 degrees. So, the maximum range is v squared times 1 over g, or just v squared over g. And that's when theta is equal to 45 degrees. So, to achieve the maximum range for a projectile when it's launched from flat ground, it must be launched at 45 degrees to the horizontal. It's probably best not to use these formulae, but rather work out the time of flight as the time when y equals 0, and then the range as the distance covered in that time. Let's have a look at an example. Example 2. In each case, find the time of flight and the range of the following projectiles. In part A, we're given the initial velocity is 35 meters per second, and it's projected at an angle of 55 degrees with the horizontal. Now, to solve this, we notice that when it hits the ground, the height y will be 0. So we've got the equation y equals vt sine theta minus a half gt squared, and we let y equal 0. Now v is 35 and theta is 55, so we've got 35t sine 55 degrees minus a half times 9.8 times t squared equals 0. Now when it lands, we know t is not equal to 0, so we can divide all the way through by t, which means 35 sine 55 minus 49t equals 0, or t is equal to 35 sine 55 divided by 4.9. And that gives us t is equal to 5.851, so our answer is the time of flight, rounded off, is 5.85 seconds. Now, to find the range, we use the formula for x. X is equal to vt cos theta. Now t is the time of flight. So we have theta is equal to 55, and that gives us x equals 35 times 5.851 cosine 55. And that works out to be 117.459, and so our answer is the range is 117.5 meters. In part B, we're given the initial velocity in vector form, that is 3345 meters per second. And if the initial velocity is 3345, then UH, the horizontal component of the initial velocity, is 33, and UV, the vertical component, is 49. Now we can calculate the height of the object using the formula y equals u little vt, that's the initial vertical velocity times t, minus a half gt squared. And we want to know when the particle lands, so y will equal 0. That gives us 0 equals 49t minus a half times 9.8 t squared. But we know when it lands, t is not equal to 0, so we can divide all the way through by t. That gives us 0 equals 49 minus 4.9t. And that rearranges as t equals 49 over 4.9, which is equal to 10. So the time of flight is 10 seconds. Now to find the range, we want to find the horizontal distance it's travelled in 10 seconds. Now we have x is equal to u little ht, and u little h is the horizontal component of the velocity, which is 33. So x is equal to 33 times 10, which is 330 metres, and so we have a range of 330 metres. In example 3, a particle is projected from ground level with a speed of 35 meters per second at an angle of 42 degrees to the horizontal, as in the diagram. We can take air resistance as being negligible. In part 1, we're asked to write down an expression for the horizontal displacement from O at time t and the vertical displacement from O at time t. Well, to solve this, we have the formula x equals v cos theta. X is the horizontal displacement. So x is equal to 35 cos 42. And we have the formula y equals v sine theta minus a half gt squared, where y is the vertical displacement. And so y equals 35 sine 42 minus 4.9 t squared. Now in part 2 we're asked to find the maximum height of the stone. We can do this resolving vertically using v squared equals u squared plus 2as. Now at the maximum height, the final velocity v will be 0, and we know the initial speed is 35 sine 42, and the acceleration a is minus 9.8. So we have 0 equals 35 sine 42 all squared minus 2 times 9.8 s. Now that rearranges as s is 35 sine 42 all squared divided by 19.6, which works out to be s is 27.98348. So rounding that off, we have the maximum height is 28.0 metres. Now in part 3 we're asked to find to 3 decimal places the time the particle is in the air. Well, to do this we can resolve vertically using s equals ut plus a half at squared with s equals 0. That is, we want to know when its height is again 0. In other words, it's just hit the ground. So 0 equals 35t sine 42 minus a half 9.8 times t squared, or minus 4.9 t squared. And because when it lands, t won't equal 0, we can divide all the way through by t. And that gives us 4.9t equals 35 sine 42, or t is equal to 35 sine 42 divided by 4.9, which works out to be 4.7795, or rounding that off to 3 decimal places, t equals 4.780. Now in part 4 we're asked to find the distance AB. Now we know the horizontal distance AB is the horizontal speed, which is 35 cos 42, times the time of flight, which is 4.7795. And that gives us 124.315, and so the distance AB is 124.3 metres. In part 5 we're asked, find when the particle is at a height of 22 metres. And we can again use the formula, resolving vertically, s equals ut plus a half at squared with s equal to 22. And that gives us 22 equals 35t sine 42 minus 4.9 t squared. Or we can rearrange that 4.9 t squared minus 23.420 t plus 22 equals 0. Now we can use the quadratic formula to solve that. We put all the terms into minus b plus or minus the square root of b squared minus 4ac all over 2a. And when we work that out we get t is equal to 3.495 or t is equal to 1.285. Now in part 6 we're asked to find the distance BC, that is the distance that it travels while it's above a height of 22 metres. Well, the distance OC is the time times the horizontal speed, so that's 3.495 times 35 cos 42, which is equal to 90.90 metres, and OB is the time 1.285 times 35 cos 42, which is 33.42 metres. So if we subtract, we get BC is equal to 57.48 metres, so we can round that off. Our answer is BC is 57.5 metres. Let's have a look at example 4. The diagram shows a clay pigeon launcher at A that fires targets into the air with a horizontal speed of 30 metres per second and a vertical speed of 40 metres per second. An archer stands at B, which is directly below the highest point on the target trajectory. The archer fires an arrow at 60 degrees to the horizontal at the instant the target is directly above him and hits the target at point E. Ignore air resistance and take G equals 10 metres per second squared. In part 1, we're asked to calculate the distance AB. Now to solve this, we first work out the time that it takes for the target to reach its maximum height. So resolving vertically and using v equals u plus at, at the highest point, its vertical velocity will be 0, so v is 0. Its initial vertical speed is 40, and taking a, the acceleration, as minus 10, that gives us 0 equals 40 minus 10t. Or 10t is equal to 40, so t is equal to 4. Now to work out the distance AB, we can resolve horizontally. The speed is a constant 30 meters per second, and we've worked out t as 4, so AB is 30t, which is 30 times 4, which is 120 meters. In part 2, we're asked to find the speed v that the archer fires his arrow. Now, since the target and the arrow have the same horizontal displacement at B and D, they must both have the same horizontal velocity. So v cos 60 is equal to 30. Now cosine of 60 is a half, so a half v is equal to 30. In other words, v is equal to 60. So the horizontal velocity of the arrow is 60 meters per second. Now in part 3, we're asked to calculate the distance BD and the distance ED. Those are the horizontal and vertical distances that the arrow travels before it hits the target. Well, let the height BF be h, and we can calculate h by resolving vertically using s equals ut plus a half at squared. Now the target is launched with a speed of 40, and it takes 4 seconds to reach F. So we have h is equal to 40 times 4 minus a half times 10 times 4 squared, which is 160 minus 80, which is 80. So at F, the target has a height of 80. Now let's take t as 0 when the arrow is fired, and we'll use s equals ut plus a half at squared vertically. Now for the arrow, its vertical speed is 60 sine 60, and so y is equal to 60t sine 60 minus 5t squared. And for the target, it's got no vertical speed, but it has a height 80. So y will equal 80 minus 5t squared. Now at E, they both have the same height. So 60t sine 60 minus 5t squared equals 80 minus 5t squared. We can cancel the 5t squared on both sides, and that leaves us with 60t sine 60 equals 80, or t equals 80 divided by 60 sine 60, which is 1.5396. Now, the distance BD is the speed of the arrow times the time it takes. So that's 1.5396 times 30, which is 46.188 n. And to find DE, we can consider the target. Now for the target, we've got y equals 80 minus 5t squared. So that's 80 minus 5 times 1.5396 squared, which is 68.148 meters. So we have BD is 46.2 meters and DE is 68.1 meters.